Okay, look at the format. It says the distance between Iowa City and Chicago on the map is 3 1/5 centimeters. What is the actual distance? Okay, so what did we need? Model over actual, 1 centimeter is 25 miles, and then 3, and I would change that to 0.2, good, centimeters. And now we want to know how many miles it is. So how do you get from 1 to 25 times 25 and 3.2 times 25? What do you guys get? 80. Ooh, they said 80.
I thought you did it by doing with the fraction. I won't put
Good job, 80. All right. Let's talk about the week we're going to follow. Start the lesson. Okay. So, all right, here we go, guys. So scale factor is a word that we talked about last week, but we didn't get really into it because we were solving it a different way. So we're going to talk more about just scale factor today, all right? It is the ratio of the lengths of two corresponding sides of two similar polygons. You need to know which shape is the original shape or old, and which shape is the image or new. Okay? You might also hear this one called the pre-image. Okay? So original, old, pre-image, all of those are synonyms. Okay? So image is the name of the new figure, which is represented by prime marks, little apostrophes, okay, like a prime. That's a prime mark, okay. So to find the missing side length, you can either use scale factor, or you can set up a proportion. I think if you'll think about those task cards from Thursday, there were some that simply said a scale factor, what's the new something or other, okay? So this is kind of a formula to find scale factor. It's new over original. Does that kind of remind you of anything else that we've looked at? This model over model over actual. So if you stop and think about it, like your original object is the actual object, and the new one is the model. See what I'm saying? Like if you're making a scale model. Okay, then that might help you. Or if you want to remember new over original, just say no. No. Okay. Whatever you want to do to help remember, okay? Okay. So I want you to take this little space and kind of divide it in half, because we're going to solve this problem both ways. All right. Quadrilateral ABCD is similar to ABCD prime. Do you see? So which one is the new one and which one is the original one? The one with the prime marks is the new. And this one is the original. And I would label that every time. Okay, because that's going to be important. All right. So method 1 is with the scale factor. It says to divide new over old and then multiply with the missing values corresponding side. Okay, so let's do that. So method 1. All right. So first, we need the scale factor. Scale factor equals new over old. It doesn't matter which ones you want to pick. We just need corresponding sides. So the corresponding sides, what are they?
12 and 8.
Okay, so 12 and 8 would be corresponding. And then 9 and 6. Does it really matter, do you think, which one I pick up? Probably not. You just might want to use numbers that not smaller necessarily, but think about working with math, right? When you're going to start working with those numbers. Which numbers do you think are going to be easier to work with? 12, 8 or 9, 6? Why not 9, 6? you get what? Repeating decimals. So I try to avoid threes, multiples of threes, as much as I can, to be honest. So I would actually pick 12 over 8. I'm saying it'll be wrong, but I would probably pick 12 over 8. So 12 over 8 is going to be our scale factor. Okay? And then, does that simplify down to what?
1.5.
Well, if I divide by 4, right, then that would be 3 over 2, which is 1.5. Okay? So now that I have my scale factor, that was step 1. Step 2 says multiply with the missing value's corresponding side. So what is the corresponding side to the missing value? 10. Excuse me, 10. So we would take our scale factor times 10. And so 3 over 2 times 10, what do you get? 15, correct? Whether you did 1.5 or whether you did 3 times 10, which is 30 divided by 2 is 15. Tell me about 9 over 6. Would we have gotten something different? 9 over 6, because isn't that equivalent to 3 over 2?
Yeah.
So it wouldn't have mattered. Okay? So what's the answer? 15. We don't know what these are, so we're just going to say units. Okay? All right. That was method 1. Okay? Now we're going to go to method 2, which is just using a proportion. Find the missing side that will make the fractions equivalent. That's just like what we've been doing. So I would put M over what? 8? It does not correspond to 8. Yeah, M over 10 would correspond. And then, oh, y'all were saying A. I thought y'all were saying number 8. And then what would I need here? Well, I started with this one, so I can use 12. 12 over what? What corresponds? 8. And then I can simplify and solve, right? So I would divide by 4. And then I would do this. Times 5, which is still 15. Okay? Is one way better than another? No. In this case, we were able to do it more than one way because I had multiple sides, right, to do it with. You may not always have that, all right? Okay, down here, something to note, all right? If you look at this example, this would be original, this would be new. They used a scale factor of 2. What happened?
The area doubled.
Right, it got what? We don't know that. But it got what? It got bigger. So the scale factor for K, by the way, y'all know why. Scale factor is represented by the letter K. I know. So when K is greater than 1, the image is bigger. Okay? What about the next one? When the scale factor was equal to 1, what happened? The same, right? Because that means all sides would be multiplied by 1, which means you're back to where you started. So K equals 1. And then on the next one, the scale factor of K is less than 1. What happened? It got smaller. And then over here, this final column, there's an entire teak that talks about this. I'll come out in just a minute, unless you just see the problem. There's a whole teak that talks about, does it preserve congruence? Okay, what does preserve mean? Keep it. It means just to keep it, right? And what does congruence mean? Same size, same shape, right? So, if the scale factor is greater than 1, does it preserve congruence? No. What if it's less equal to 1? Yes. What if it's less than 1? No, because it's straight keep. Okay? So no, yes, no. All right? All right, let's go on the next page. You think you guys can go ahead and figure out that first one? Just the first one and then pause there, okay? You're at home, pause. Okay, so this one's a little bit different. It's asking what scale factor was used to dilate WXYZ to to W, X, Y, Z prime. The first thing you want to pay attention to is which one is which. This is the old one. This is the new one. So scale factor is new over original. 20 over 10, which equals 2. Did you guys get 2? Okay. There's a couple of symbols up here that you may or may not see. The symbols are similar. Looks like that. It's like a tilde. Okay. But congruent is that. Okay. So it's like a little squiggle with an equal sign because it's congruent. They're supposed to be the same. Okay. Okay. Let's look at the next one. We're going to do this one together. All right. In the diagram below, ABC is similar to DEC. And then blah, 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 find the length of AB. Triangle DEC was dilated to create triangle ABC. Use scale factor to solve. Now, first of all, could we already have solved that problem? Yes, because we already had one, I think, really similar to this one last week. The new part is they're telling you to use the scale factor to solve. So you cannot cheat on this one. In the future, will it matter which one you use for rate, proportional, scale factor? No. But for right now, I want you to practice with scale factor. So what is our step 1 going to be? Separate them. That's right. C, B, B, C, A, B. Put in our labels. DE is 5. In fact, I'm pretty sure we saw this exact thing, maybe on a warm-up or something. DA is 2, and they want AB. Okay? That's what we're looking for. If I recall, when we had this for our warm-up, we figured out this missing side right here by doing what? Adding the 10 and the 2 to get 12. And we still can. And we can set up a proportion, and I'm pretty sure everybody in here already knows the answer, which is what? Does anybody know? Remember? No? Okay, good. We forgot. So let's do scale factor. So new over original. You have to go back to this statement right here. DEC was dilated to create ABC. What does that mean?
ABC is DEC prime.
Yes, these are the new ones. These really should be prime. And this is the old. Okay, so then that means what am I going to put up here? Y12.
Because it's part of the new.
Because that's the only number on the new one. Okay, and what's going to go under here? And how do you know? That's the word I was looking for. It corresponds. Okay, so now that I can simplify that down to 1.2 or 6 over 5. Okay, and then what do I need to do with this? Yeah, I need to take my scale factor and multiply that by the corresponding side to get to x. And 1.2 times 5 would be 6. Okay, and again, I know you already knew how to do this because we solved it last week, I'm pretty sure. But I just wanted to show you how to use the scale factor to do it. Okay, so guys, go ahead and try the next 2. I think I'll show them the next 2, okay? Pause the video here. Okay, on the first one, I got 5 and 5/8. Same thing. On the second one, it was a little bit different because you had to remember that it's scale factor times old equals the new, right? And the unknown was on the old, so that's why you actually had to set up an equation for that one. Did y'all do that? Or did anybody put 27 as your answer? I started to, just be honest. I started to, because I was like, wait, that can't be right. And here's another thing. If you check your answer, if you did put 27, do you see how that can't be right?
Yeah.
Because if you look from here to here, what happened? They divided by 3 and it got smaller. So then to get to this, that would also be dividing by 3, right? So I'm just saying that, yeah, okay? All right, any questions so far? How are we doing? Okay,
So you do the scale factor.
you can, that's one you can. Okay, so this is what I have for us. We have about 15 more minutes, okay? So I have some test cards that you don't have, and I thought we could play the lottery with those. Okay, have we done the lottery this year? I don't think, have we? I don't know. I'm gonna review, I know we did last year, but I wanna review the rules, okay? Guys,